let's start off by getting the repo down and getting a development environment set up. So first thing I'm going to do is go to the Ipyleaflet repo, and I'm going to get the URL to clone. So I've made a new directory called cluster, and I'm going to first start out by cloning.
Could you make that like one font size bigger or something there? Okay.
Is that better?
Yeah, maybe even there we go. That's good. Can everybody see that okay? Or if anybody can't see it okay, please let us know. Should be good.
All right. Okay, so now I'm inside the Ipyleaflet repo. So next thing I want to do is set up a new Conda environment that I'm going to install this Ipyleaflet repo in, make sure things are working, and make sure that I've installed it so that my changes to Ipyleaflet are reflected in my running demo that I'm going to be checking things in. So what I'm going to do is I'm going to create a new Conda environment. Let's call it cluster. Actually, I have a naming convention. I'll call it dev leaflet or whatever. Okay, so in this environment, I want to install the notebook, and I want to install Ipywidgets. And I think that's probably enough. So this pulls, I set up my Conda environment to pull things automatically from the Conda Forge channel. So otherwise I would have done the -c Conda Forge. But you can see here, and I'll just check, I'm getting the latest release of Ipywidgets on the Conda Forge channel, and I've got the notebook coming in too. So we'll go ahead and proceed. It'll take a couple seconds. So it says that organizer stopped sharing my webcam.
Yeah, is that okay?
But you can still see my screen, right?
Yeah, I just wanted to get a little more real estate.
Yep, no problem.
Yep.
So give this a sec. Usually it goes quite a bit faster. Okay, and so next thing I want to do is activate that environment. And then I'm going to run a command, but I'll show you what the command is. I've got a small script file because I often do this where I create a new environment, and now I need to create a kernel tied to this environment. The reason is I've installed Ipywidgets, the Python side, into the kernel, and when I am going to do some testing, I want to start up a notebook using that version of Ipywidgets from this environment. So essentially, I'm running IPython kernel install. In fact, I'll just run it explicitly. Usually, I just type kernel env and it does things for me, but IPyKernel install name, and I'm going to call it the same thing, devleaf, as my environment, so it's clearer. Display name, I'll just leave that. Here we go. Okay, so now I'm going to check things by starting up the Jupyter Notebook. So here's my notebook, and sorry, let me close. I'm not paying attention to the chat, so I'll depend on Richard to notify me if there's anything in the chat. Okay, so now my new notebooks, I have some system-wide environments that I have set up, and then I have the devleaf. And so let me just check that Ipywidgets is working. I guess I have to, from Ipywidgets, import star. Okay, so Ipywidgets seems like it's working. I'm rendering widgets. So this is good. Okay, so let's close down this. And now the next thing I want to do is install Ipyleaflet. So make this a little bit bigger. I think Ipyleaflet is set up so that you can just pip install it. And again, I make sure that I'm in this environment. So I'm installing into my devleaf environment. And I'm going to install with a -e, which means install it in dev mode, which basically means instead of making a copy of this and installing it into Python, I'm going to have Python actually point to this exact directory, which means that my changes in this directory will be automatically visible in the Python path. So I'm going to pip install it. So this installs the Python package. which for Ipi Leaflet, let's see, there we are. Let me just double check. Sometimes our packages are set up to automatically do the JavaScript generation. It doesn't look like it did the JavaScript generation. And if I read the README, it probably would mention as much.
So could you have installed with like, would another way to be is like install it with Anaconda and then you get all the dependencies and then remove Ipi Leaflet and then pip install just that or something, or just so you wouldn't?
Yeah.
Oh, okay. Oh,
yep.
no, you already had it.
That would be,
okay.
Because I installed Ipi widgets, I think that's the only dependency, and installed the notebook.
Okay.
You could, I do that sometimes as well, where I install, yeah, okay, so here's the instructions here, pip install -e dot. So I've cloned, I've gone into that directory, I've pip installed it, and then there's two further instructions, the Jupyter MB extension it, install and enable. And what these do, in fact, I don't even, you may not need to do the install, but we'll do it. Oh, we need to do the install. Okay, so what these are doing is it's actually installing the JavaScript in a place where the notebook is going to find it. So if you remember, and I'm assuming a background sort of basic fundamental understanding of how widgets work, there's two components to the widgets. There's the kernel side Python package, and then there's a JavaScript browser side package. And pip install has installed the Python package into the kernel, and it's copied over, or in our case, pointed to the JavaScript assets inside of my package. But the notebook doesn't know about those yet, and that's what the MB extension install and enable does, is it copies those JavaScript files over to somewhere where the notebook is going to look for them. So these steps are important to make it available to the notebook, and in particular in a dev mode, this command is important. What it says is that instead of copying the JavaScript over to somewhere where the notebook can find it, I'm going to point to my my existing directory here. So that when I change the JavaScript and rebuild the JavaScript, that the notebook will look in this specific directory instead of a copy I had previously made.
Great. Okay.
So I'm just gonna copy these two commands directly, and then the second command is in the README, but it's also helpfully printed out right here. And when you install it, it gives you the command that you need to run to enable it. Okay, and I'll check by Jupyter NB extension list, which says that I have Jupyter.js widgets and Jupyter Leaflet. Okay, so let's check to make sure that works. So I'm going to start Jupyter Notebook in this directory, because I know I have the examples folder. And I'll close down the previous tabs for Jupyter Notebook. And I'll just go into the examples folder and make sure that one of these works. Let's see, was there a good notebook to check this here? Yep, okay, so I have Ipi Leaflet working. And, yep, okay. And yeah, seems like it's working great. Okay, so now I'm set up for development. So at this point, I need to think about what I want to develop here. And I think we decided to add the clustering thing. So let me look up that. Google can, let's see. There was an issue, I think, even about it, right?
I think so.
Marker cluster, here we are.
Yeah.
And I think it pointed to the Ipi Leaflet. Oh, it didn't point to the right Ipi Leaflet marker. Okay, so marker cluster is the thing to search here, search for. So Ipi Leaflet, or sorry, not Ipi Leaflet, just Leaflet marker cluster. All right, so here's the. Looks like here is.
Could you do Control plus just one time on this, just to make it a little easier on the eyes? Yeah. Okay. Thank you.
Better?
Yep.
Okay, so it appears that the syntax. I'm just going to look and see how it's used in JavaScript. It appears that essentially instead of adding, when I have a JavaScript map, typically I would map.add layer a particular marker. And it appears that all I do is instead of adding markers individually, what I do is I create a new marker cluster group, and then I add the markers to the marker cluster group with using the add layer, and then I add the marker cluster group to this. So it seems like a fairly simple, like 2 or 3 lines that we eventually want to affect in the JavaScript change here.
Mm-hmm.
So this looks promising that we might be able to get it done, or at least make progress on it in the next hour. Okay. So I haven't, at Richard's request, I haven't played too much with this. I haven't downloaded the code or tried it out or anything like that. I've basically looked up this page right here, so we'll sort of fumble through things together here. It looks like the first thing I probably need to do is npm install this dependency so that I have it available. So let's go to the JS directory. JS directory is where all of the JavaScript for this package is, and you'll notice the package JSON. And so this is all the dependencies that are pulled in. You can see we've got some standard dependencies, like here this plugin's pulling in Leaflet. So we want to pull in this new npm package, which is, I guess, leaflet.markerCluster. So what I'll do is I'll npm install and -- save in order to save it to my package JSON, and leaflet.markerCluster. So now I'm pulling in this dependency. And I'll just check the package JSON, make sure it's there now. Yep, I've got the leaflet marker cluster. Okay, so now I have the software. Now I need to integrate it, use it inside the package. So there's 2 places that I need to make changes. I need to make changes in the Python side and in the JavaScript side. In the Python side, I need to add a new class that the user will be using from their code. And then in the JavaScript side, I need to add a new section in the code that will interact with the Python class that I'm adding. Let's add the Python class first. Okay, so I'm going to start up a new code editor, Visual Studio Code, which is what I've been typically using these days. Looks like I got upgraded, which is always great to see. Okay, so I'm going to go to the Python side. Can you see this? I think I can make it bigger.
Yeah, that's fine. Yeah, one.
Okay. One more?
Yeah, one more probably. Yeah, that's perfect. Yeah.
Okay, I'm going to minimize the GoToMeeting there. Make this a little bigger. Okay. All right, so let's look at the Python code. So here's my Python code. In fact, I'm going to, if I maximize this, do you see it on this? Do you see it on the screen sharing?
I mean, it still looks okay.
It still looks okay. Okay, great. Can I go one less just to fit a little more on the screen?
Yeah, I think that's fine. Yeah, okay. and it's really just about, I'm just worried about the recording, really, not as much because I forget what the resolution is, but it's not quite always exactly what we're seeing on our anyway. But I think it's something fine.
Okay, let's go with this one. It's a lot easier to work in and see what we're dealing with. Okay, it sounds like basically the marker cluster is going to be similar to the marker. So I'm going down looking at these widget Python classes, and here's some standard sort of boilerplate in these classes. In fact, all the underscore methods are sort of standard boilerplate. Looks like we have a top level layer class and then that subclass below, if I remember right. So here's the marker. And the thing we're doing, it seems like it's kind of similar to the marker. We want to treat it as a layer because on the JavaScript side, we use it with an add layer command. So I think it makes sense to treat it as a layer. Let's look at some of the other Python classes. We have another layer here, tile layer, image overlay, vector overlay, path, polyline, rectangle, circle, circle marker, layer group. So that looks interesting. The interesting thing about this is it has a layers attribute that's a list of layers. So that's actually similar to what we want with the marker cluster. I imagine that we'll create a marker cluster and we'll add some markers to it, a list of markers to it. So this looks similar to what we want to do. And let's see, we've got feature group and GeoJSON and a few other things. So actually, I'm going to take this layer group as sort of a template for what I want to do with the marker cluster. So actually, I'll just go copy it right here. And I think if I remember right, looking at the marker cluster documentation, it can actually handle not just a list of markers, but it can also handle, like if you pass it a GeoJSON layer, it'll go through and actually pull out things in that GeoJSON layer that look like they can be clustered. So the point GeoJSON data. We won't worry about that for right now. Maybe our goal for right now is just to be able to construct a bunch of markers, add it to the marker layer, and then add the marker layer to the map, to the cluster.
That sounds perfect. That seems perfect. Yeah.
Okay. So for now, how about let's call this markers, and instead of a generic layer, so this is a typing syntax. This is this what you're looking at is basically traitlets code here, using a traitlets library, and it's giving some indication of the typing of this attribute. So it's a list of classes that are of instances of class layer, and let's make this a little bit more specific. Say we want markers to be a list of markers. And everything else looks fine. Okay, I'm going to do two more things. I'm going to change this to tuple instead of list, which is sort of a recommended thing to use tuple instead of list. The reason is that tuples are immutable, and we don't have a good abstraction for lists, communicating changes in lists. And because we don't have a good abstraction for communicating changes in lists, the problem that we have is if you had in your Python code, you know, let's say cluster equals layer group, and then you set the cluster markers to be some list of markers, so A, B, and C. If you have a list type here, what ends up happening is it gets really confusing if you do something like this. And here I've changed that list, but since we don't have a good abstraction for communicating changes, we don't recognize there's a change, and there's no and the change is not sent over to Python or JavaScript, and things are not updated, etc. So what we've taken to having right now, at least, is a convention of using tuple instead, which would make this throw an error because cluster.markers is a tuple. Instead, what we would have to do in this case is actually assign cluster.markers all over again. So D, B, C, like that. And this change is appropriately propagated. If you completely reassigned a markers attribute, then the change is appropriately propagated to JavaScript. So as a convention, what we've done is instead of using lists like this, and we should probably change this as well, use tuples instead. So I'm going to use tuple here, and I want this to be a tuple of markers. And these tags here are widget sort of specific things. The sync equals true means this attribute is propagated over to the JavaScript side, and it receives updates from the JavaScript side. And the widget star widget serialization is just a dictionary that says for this particular attribute, you know, on the Python side, we're going to have these classes, but when they actually get sent over to JavaScript, what we're going to do is extract out the widget model ID and send it over. Basically, it's just telling this class, this layer group, how to serialize its markers to and from JavaScript. And the widget serialization, that's a standard widget thing. In fact, you'll see at the very top of the file, we just imported it right here from Ipi widgets. It's a standard way of serializing widgets. And here, again, the layer group. Here, what we have is a list of widgets, a list of markers. So this gives us a way to seamlessly get a reference to another widget over to the JavaScript side. And I guess we should call this marker cluster. All right, questions up to this point?
Well, okay, yeah. So I think this makes sense. When you the interaction, the functionality, like when you're in Leaflet and you click on you get a marker cluster. You have a bunch of markers. You get a cluster, then you click on the cluster. You know, if you zoom in, they split out into the individual markers. That's all good. Is that all going to be handled here somehow, or do you have to handle
Yeah.
that?
Yeah, we don't have to deal with any of that. That's all
Okay.
in that leaflet marker cluster marker library.
Yep.
Here, we're just providing an API for the user to construct the data structure of a cluster is something that contains a list of markers, and we're sending that over to JavaScript. And then in JavaScript, we'll handle the list of clusters,
Yep. Okay.
or the list of markers, and adding that to the map. And then the library actually does all of that UI for us.
So when you end up like zooming in and you want to click on a marker and send that back to Python, that's all. That's just going to come back through the marker class or whatever.
Yeah, if I remember right, yeah, I think so. If I remember right, the events, it says leaflet events like click, mouse over are just related to markers in the cluster.
Okay.
So essentially, I think things are just passed through to the markers.
Yep. Okay.
And you could think about the cluster, and I think that's how it works. I haven't played with it yet. We'll see just in a minute. But I think the clustering is literally just like a UI layer, and it passes through events unless you add specific events for the cluster, which we won't do today.
Okay.
Okay.
Yeah, anybody else have a question? You might have to unmute yourself. Okay.
Okay, and I noticed there's one other change that we need to make, and we need, actually, that's odd that this is a typo here. So we'll fix this as well. We want the view name and the model name to be distinct for this thing. So leaflet, what are we calling it? Marker cluster view and leaflet marker cluster model. And I'll just adopt the convention that I'm seeing everything else in this file is using. Okay. So I think this is the Python side. This looks good to me. So now the question is what to do on the JavaScript side. So let's go over to the JavaScript code. And again, per Richard's request, I didn't look at this very carefully or very long at all. I think it's in this file right here. Certainly seems like a long JavaScript file. And let's search for layer group since we're taking that sort of as our model. Okay. So there's typically two JavaScript classes. There's a view class and the model class. The model class is the thing that is communicating with the Python side and storing the attributes of whatever's stored on the Python side. And then there's the view class, which is rendering those attributes onto the page somewhere. And typically in the communication, you have one model for every Python object, and then possibly multiple views. Every time you display that Python object, you get a new view associated with the same model. So this looks like the leaflet layer group view, which actually is a pretty simple class here. And let's look for the model as well. Here's the model. So I think that's the only places that layer group is used. And then down at the very bottom, it looks like we have a huge list of just exports of the different classes. So we'll need to add ourselves in there as well.
Jason,
all right, so let's,
on that one?
Yeah.
Sorry to jump in. Was there that same typo in that view being repeated twice in the JavaScript that I just see?
Let's see. Yep, it looks like it. Thank you. So we want to be consistent with the view name and the model names. These are sort of the keys that are used to distinguish this particular object. So, yep, good call. Very, very good catch there. So I'm just going to go ahead and just like with the marker cluster, just copy and paste this in here. And it looks like I have 2 lines in between each one as a convention. Okay, so first thing we'll do is call this, what did we call it? Marker cluster?
Yeah.
Or is it cluster marker? Marker cluster. Okay. And so what this is doing is it's just like in Python side, we were extending the class subclassing it. This is essentially subclassing it in JavaScript. We like the right plugins these days in TypeScript, which provide a much more object-oriented ES6 syntax. This plugin was one of the first plugins written, and so it's still using plain JavaScript. But we'll roll with that for here, and eventually one of these days it might be interesting to convert it over to TypeScript. But let's see, it would be minimal changes at this point. This is saying this extend is saying we want a subclass leaflet layer model, essentially. And the defaults, what this is doing is it's saying those attributes that we have on the Python side, we want to declare the same attributes over here and give them default values so that the JavaScript object doesn't can be instantiated by itself and have all the appropriate attributes that we expect the marker cluster to have. And so we didn't change those attributes over on the Python side. We just changed what they consisted of is the same named attributes. And so again, here we won't change very much here. The defaults essentially extend says we want to make what we're going to do is take this dictionary right here, this JavaScript object right here, and we're going to add to it the defaults from our superclass, and then we're going to override those with these three things. And so again here, we want the view name and the model name to be marker cluster, and the layers is still a list. Now we're dealing in JavaScript here. There's no distinction between lists and tuples. In JavaScript, it's always just a list here.
So is this a leaflet layer model or a leaflet marker model?
This is a leaflet. This is a model for that Python class that we just created.
I mean, sorry, that you're extending there.
Right here?
Yeah.
Is that what you're asking?
Yeah, I was asking if
that was... So if you remember the Python class, let me put the Python class over here. What I'm doing is I'm just mirroring what's happening in the Python class. And in the Python class, I extended the layer, which is this sort of generic Python object representing a layer in Ipi and Leaflet. And I'm doing the same here. Okay. There we go. There it is. I'm extending the same here. I'm extending the same model on the JavaScript side as I am on the Python side. And the reason for that is consistency, that I have some attributes probably that are part of this layer object here, and I want to make sure that I'm picking up those same attributes here in the JavaScript side. I wanted there to be consistency between these two models. Okay. Next is the serializers. Actually, let me make this. Here we are. Oops. There we are. Okay, so the next attribute here, technically you can think about this first dictionary. So there's two parameters to this extend function. The first is sort of instance specific parameters, and the second is you can think about it as static parameters if you're used to object-oriented languages. Convention is we put the serializers on the JavaScript side as static attributes, or you can just think about this as some boilerplate code. And we're not going to change this. This is essentially saying that layers here, its serialization is going to be this line right here corresponds to, let me pull back up the Python code and pull it over to the side here. I keep losing my place here. Okay, so basically what we have is an attribute here, markers, but we do have to change that, I guess. Instead of layers, this is now called markers. And this is called markers. basically, when you're dealing with serialization, you need to make sure both sides are speaking the same language. And so here are the two counterparts, this deserialize handler and this star widget serialization. These are convenience methods that we use a lot in Ipi widgets, and it's basically just setting up a serialization protocol for references to other widgets. And so what happens is you create some markers in the Python side. You know, they're living objects, they're living instances on the Python side, and this marker cluster is going to contain some references to them. In this attribute, it'll be a list of those markers. And when we want to send those markers over to the JavaScript side, what we really want to do is, instead of sending each individual marker over, the markers have already been communicated to the JavaScript side when they were created. We just want to send some references to those markers. And that's what this widget serialization protocol is doing. It's essentially saying, you know, you already know about marker 5, 6, and 7. My markers list that I want you to know about is a list of go find marker 5, go find marker 6, and go find marker 7 that you already know about and put them in a list. It's a direct reference to the corresponding objects on the JavaScript side. And the same here, this deserialization handler, it's basically the other end of that. It gets a message from the Python side that says, you know, marker 5, 6, and 7 is what I want you to put in this list here. And what this does is it actually goes and finds markers 5, 6, and 7 JavaScript models and puts a reference to them in a list. So in a sense, these are sort of boilerplate for communicating references to other widgets. And the only changes I need to make, because the class is so similar, it's just a list of references to other widgets. The only change that I needed to make is the name of the property here, markers and markers.
Can I just, Colin, Philippe, you guys, is this making sense? I just want to pull a few people.
Yeah, it's making sense.
It's stretching my my comprehension, but go ahead.
Yeah, there's a
specific question.
Okay, there are a lot of sort of grown conventions in widgets that are being exposed here. So don't be ashamed or whatever of being overwhelmed here.
Yeah, and I'm not a JavaScript expert by any stretch, so
right.
That's
sure.
part of my issue.
Sure.
Massimo, how about you, Massimo? He's muted. Okay.
Well, same here, Jason, but this is good because now I know how to ask questions. At first, I have no idea even how to start. So it's awesome, the session.
Okay. So now we have the model. So again, basically we create one of these classes on the Python side, and that automatically, when it's created, creates one of these classes on the JavaScript side, and it communicates the attributes and sets up a framework where these attributes are, you know, in particular this markers attribute, communicates back and forth any changes on either side. And there's a one-to-one relationship. An instance of this class here has an instance of this model over here as, you know, sort of corresponding objects. Now, the second part of this is creating the views. So the views will live on the JavaScript side, and what they're responsible for is rendering into an actual leaflet map the data that's associated with this model here. And there can be many different views on the page. Every time you display this object over here, it'll create new views associated with this model over here. Can you see my cursor, my mouse?
Yeah. Yep.
Okay. So you can see where I'm pointing. Okay. So every time you display this, it'll create a new view associated with this particular model. And so that view will have access to this model, and it's responsible for rendering and using this cluster library that we have onto a map. So that's the next step. So let's go ahead and, I guess it's not called marker cluster, it's still called layer group. I guess it's the view. Okay, so we have a couple of, so here's the view class. We'll come to that yeah, let's go ahead and do that now. So again, because we're so similar to this layer group view, I'm just going to go ahead and copy this code and use it as a template and try to obey the conventions that I see around here and change the name. And let's see. So this is where things get a little bit specific about how Ipi Leaflet does its rendering. And we're going to get a little bit technical into how Leaflet works and how Ipi Leaflet works. Essentially, essentially what we're doing is we're constructing a tree of objects, a tree of JavaScript objects, and we want to compose them together using the leaflet commands. So you have a map that's a leaflet map, and you want to add markers and clusters of markers and circles, etc. And what Ipi Leaflet looks like it has done, and I wasn't the original author of this library, but it looks like it's patterned after what we did in Py3.js, and that is if you want to create an entire tree of JavaScript objects and link them together using some library, what you end up doing is having each view class have a create object method, and it's responsible for creating a leaflet object representing whatever the data is that you have. And then we have some automatic infrastructure for chaining those leaflet objects together. And so I'm just browsing through the class here, and it looks like here's some of this automatic thing. You know, if you inherited from layer, which we did, then the render function is what's called by Ipi widgets when it needs to display this object. And what it's going to do is first create that object, and this function is subclassed by the different views. So it'll do whatever it needs to do to create this leaflet object, and then it'll call this function and then call this function. It looks like those two functions are just empty in the superclass, and then presumably in various views they're overridden. So let's look down here. So essentially what happens, I think, here's an example for a marker. The create object method is responsible for creating an actual leaflet object, and here's where it does that right here. It creates a leaflet marker, and it uses attributes from the model. So the model, this.model represents the model that is associated with the view. So for a marker, for example, let's see, here's layer, here's marker. So here's the marker data, and in particular, marker has a location. Oh, it keeps jumping on me, sorry. Here we are. So the marker model has a location element, and that location element is communicated to a marker model on the JavaScript side. And then the view, this is the marker view, it has access to that model, which means it has access to this data attribute in the this.model. So this is the actual leaflet syntax here. L.marker, it's getting the location from the data attribute that was communicated from the Python side. And then it does this get options and then a bunch of other stuff, it looks like, and it sets up some handlers for listening to events on the marker, etc. Okay, so looks like our responsibility is to create an object called this.obj. That looks like our responsibility in this create obj function. Create an object that's a leaflet object. So yeah, all the way through here, here's a much simpler example. So a polyline view, which corresponds to a Python class somewhere here, polyline. I've got locations, I've got smooth factor and no clip, which I assume is somewhere in this get options. And the responsibility of the create object function is to set this.object to an actual leaflet object that I've created from my data in the model. So following that pattern, here we'll go look up the syntax for creating the actual marker cluster. So let's go back to that example that we saw on the marker cluster, and I don't have any sort of experience with this. I'm just going to basically copy and paste this. Actually, that looks like a very specific, that had icon create function. Let's just take the sort of simplest one right here. So I don't need to add the layer. I noticed none of those others, all they're responsible for is creating an object. They're not adding layers or anything like that. What we're doing is doing something like this, marker cluster group. And then I need to figure out how to get the markers from my views that are the list elements into here. So the first thing is, let's see. So this object is a marker cluster group. Okay, so there's our leaflet object. And then somewhere, something needs to happen that puts the actual markers into this this .obj. So this .obj is the marker cluster group. So let's look down here in some of these feature groups. So even this feature group here, it looks like it's not actually responsible for adding the child objects in here. So that's a question in my mind, is how do the feature group objects actually get added to the leaflet object here? So let's maybe look for add layer, because that looks like the appropriate command. Where does add layer happen? So here's a draw view control. That doesn't, it looks like there's 5 places that that add layer happens. What says it? Oh, it's still the draw view control. Let's see. Add layer. So here's the base class, the map view, and somewhere in there it's adding layers. So let's try to see what's happening here. And again, I didn't write this code originally. Brian Granger originally wrote it. Sylvan Corley has touched it a lot. I'm not familiar with this code, so we're sort of looking at it together here. And per Rich's request, I didn't try to read the entire library before I came here.
No, that's fine. And in fact, and also don't worry about the hard the deadline unless you need to drop off at 4 o'clock. I imagine some other people will need to drop off. Sorry, 4 o'clock Eastern. But if you don't need to, yeah, we can just keep on going for a while if you want, if you're willing.
I think I can push forward at least a little bit more.
Okay.
Let's go and see where we are in 10 minutes.
Yeah.
Okay, so create child view. What this function does is it creates a view of a child model. So here, we have various children. Let's go to the map model here. Let's see, it should be at the very top level. So there's the layer. I want to see the actual Python model that corresponds to the class that we're dealing with here. So I'm scrolling through here for all the layers, and probably the map is towards the bottom here.
There it is. Yeah.
Map. Yep, there's map. Okay, so it's got some notion of children, probably, or layers or something. There's a lot of stuff in this Python class. Options, a lot of property. There we are. Layers, and it does use recommended tuple instead of a list. Okay, so it has a bunch of layers, and here's my view. Here's the render method. There's the render method. This is the function that's called to actually put it on the page. So what happens in a map? It gets the width and the height from the Python model, which is communicated to a JavaScript model. It creates a data structure we call the view list. Basically, what a view list is it's a list of things, and anytime something is added to that list of things, we call this function with that thing. And anytime something is removed from that list of things, we call this function with that thing. And so what this does is it lets us basically keep in sync a list of things, keep a list of leaflet things in sync with what the models list is. And so basically what happens here is as my layers here, as these layers change, It's going to call add layer anytime a new thing is added to this layers tuple, and it's called remove layer view anytime something's removed. And so these functions jobs are to actually add and remove it from the actual leaflet map that we're creating here. And okay, so add layer model, remove layer model. So that is where these two functions come in. Anytime I add something or subtract something, anytime I change this layers list, it's going to appropriately call the add layer model or remove layer. Wait, what were those two functions again? Add layer model, remove layer view. That's kind of a little confusing. Remove layer view, add layer model. Okay, so add layer model, what it does is takes the model that's being added and it creates a new view for that model. And then it uses, this is a leaflet add layer function. It adds that child view.object. Okay, so that child view, remember it had a create obj function that's automatically run whenever that child view is rendered. And that adds to the child view's obj attribute that creates that child view's obj attribute. And so then the add layer model, what it does is it takes that obj attribute, which is a leaflet object, and it uses and it adds to the map using the leaflet add layer command. Okay, so what happens is the map is sitting here. The maps is the object member object attribute of this class, and whenever I have a new layer added to the map, it's going to create that child view, which should automatically create the child view.obj. And then once that's created, and child view.obj is the leaflet object. I'm going to add that child leaflet object to my map leaflet object. So things seem to be fine here, except now I just need to make sure that the one thing that's missing here is that I don't have just a single leaflet object here. I have a leaflet object that needs to create a bunch of children leaflet objects and add it to itself, and then it's ready to be added to the parent map. So I think basically this is the sort of code that I need to have. I'm a little surprised that it's not in the layer group code. Is there an example using the layer group? Do you know? Does it work correctly? I guess that's my question.
Yeah, right. Massimo says no.
There isn't an example. Okay, so I have a question whether it works or not.
Yeah, right. I guess that's a little bit, would be a little unfortunate if we were copying something that didn't work, huh?
Well, it looks like it just wasn't implemented. So here the draw control, when it's rendered, it actually creates a child view of, so the draw control has a layer attribute, and it's going to create a child view of that layer attribute, and then it's going to, it looks like map view is the actual map. It's going to directly add to the map view object. Looks like there's something to be fixed here. Okay, so what I think needs to happen is just like the map view. Wait, what's this? No, it's the same sort of thing. Just like the map view has this view list, I think we need to create a new view list inside of the marker cluster. Okay, question?
Well, I was just going to comment that Massimo said in the chat, it looks like there's some placeholder in the JavaScript code. But I guess that was in reference to the, actually, Massimo, can you unmute yourself? Yeah, I'm not sure.
Yeah, since there are some functionalities that they are never called back in the JS, like the group layer, I tried to see if it was implemented, seems that it's not.
So so the stuff we're doing is probably exactly the same sort of stuff you would add to the group, to the layer group stuff. So I actually do have to go, but we can pick up this at a later time. But basically what I think needs to happen is, this is the map view. The marker cluster view needs to do essentially the same thing the map view is doing with regards to its markers. So just like the map view has a layers attribute, the marker cluster and the layer group cluster should probably have exactly this same sort of code for their layers and clusters attributes. So essentially what needs to happen is this line needs to be copied over. Maybe, okay, let me take just a couple minutes, see how fast we can go through this. So I'm going to create a new layer views. Okay, that's fine. Let's see, let's get, can I make a new copy of this file? I forget in Visual Studio Code if I can see a new copy of this. I haven't done this very often in this editor. And let me see if I can just do it here. Let me see if I can. Yes, perfect. Okay, so I'm just gonna copy and paste code. Okay, so here I have create object, and I also want a render. Actually, yeah, so in the render function, what I want to do is keeps jumping when I click over to it. I'll have to draw control. Here we are. So I want to create a new view list. Hope this doesn't jump. Oh, good. And add layer model and remove layer view. Let's copy those functions over to remove layer view. And appropriate commas in. Okay, so and then in the create object function, which is automatically called when I call the super. So let's see. This is a little bit painful in standard JavaScript. It'd be much cleaner in ES6 syntax with TypeScript. So here I call the super. That automatically calls the create object, which creates the marker cluster group. And then what I want to do is, let's see, this view list is going to be, let's see, how do we associate the view list with this particular attribute, this dot layer model, this dot remove layer model. Where are we? Somewhere there's an association between this view list and the actual layers, this dot models dot layers. I guess we could search for it. Looks like I'm not finding it. Okay, so we need to make an association somehow. We've got a view list. We need to associate this view list with the markers. And anytime something is added to that view list, which is a model, then we want to create the child view. Great. Map view doesn't make any sense. I guess we probably want to say we'll pass down the map view that we have. And with this child view, now the child view has an object, which is that leaflet marker, and we're going to add it to the marker cluster, that.obj.addLayer. So this is where we actually add the child's marker to ourselves, to the cluster group. And then we return the child view. And when we remove child view, we're going to remove the marker from our object. So this.obj is the marker cluster. Child view.obj is the marker, and this is the leaflet function. We're going to call the leaflet function to remove that layer. And then we're going to kill the child view. So this deletes the child view. And I think, so that's essentially doing this part right here and from the example, add layer, and the marker is the child view obj. So we've got a view list, this, and that's layer views, and this is going to take care of the logic for adding and removing the child markers from the marker cluster. And the super is creating this object, which is the actual marker cluster group, and that will automatically get added to the map based on the maps view list logic here. So the one thing we have to do now, I think, is to associate layers, changes in the models children. Let's see, I guess let's call this marker views. Changes in the markers, the model's markers attribute with this view list here. And I'm a little, let's see, what we want is change. Here we are. Right. So model events, where is this? They delegate all of this change setting up to this model events function, which is called, in the render. Got it, okay. So I just need to, sorry, my cursor keeps jumping here. So here, this super render function is going to call create obj, so it calls this function. Then it's going to call leaflet events. We don't have any leaflet events we're setting up. And then it's going to call model events. So it looks like the design of this library is such that I set up a new model events function. And it's responsible for listening to model changes and affecting my view however it needs to. And so as an example, here's an example of the syntax here. So I want to listen to the model and a change on layers. And anytime there's a change on layers, I'm going to update this view list. So I'm actually going to, this is exactly the sort of thing that I want to do. And here's the marker cluster view. Listen to the model, any change on markers, then function this dot layer views. So I guess it's my view list is marker views. update this model.get markers. Okay. So I render, I call the super, it calls create obj, and it calls this thing, which sets up my change handler to listen for changes on the markers attribute. And then it sets up this marker views widget list. And it says basically anytime there's a change in markers, this update function will call this function or this function as appropriate. This add layer function, add layer model, what it does is it creates the child marker view, and then it adds the leaflet marker to the leaflet marker cluster using the leaflet add layer function. And anytime there's a change which involves removing a marker, it calls this function, which takes that leaflet marker and removes it from the marker cluster leaflet thing using the leaflet remove layer. So I think actually this should be good to go. So the one last thing we need to do is we need to import this package. So let's see, I think we can just like this leaflet draw, we can just require, what was it called again? The npm package, leaflet.marker cluster. So that adds the package. And then the last thing to do is add it down here. So we want to add the view. Let's call it marker cluster. Marker cluster view, and then same thing for the model. Okay. So everyone want to cross their fingers?
No, we want to see how you debug stuff. If it worked the first time, that'd be so
disheartening.
Yeah, right.
Okay, so let me close down everything.
I understand we might have to save that for another time or exercise to the student, but
yeah, let's launch the notebook. And we'll try to pick an example that has a marker. Do you know any of these that have markers in them? I think primitives might.
Yeah, I can't. Yeah, there's, I guess, some.
There it is. There's marker. Okay, so let's go ahead and hopefully things haven't been, okay, great. And let's make sure marker works. Oh, wait, let's see. Yep, we have a marker up there. Okay, so let's add some new cells here. And first make sure marker cluster is available. Let's see, did we import everything? Oh, we need to import marker cluster.
Comma, yep.
Yep. Okay. And so let's make a bunch of markers, say in the center, right? Those should be clustered.
Yep.
And we'll just make it a list. Okay, and I guess we have to put commas after each one. Okay, and let's see. Okay, our first error. The markers trait of a marker cluster instance requires one element, but a value of, let's see. Yeah, okay, so this is a simple one to fix. And it's just some syntactic things with the tuple. we want tuple trait equals instance layer instead of the syntax that I did. Let's do. Sorry, I'm just trying to find where it is. Let's see. Yeah, marker cluster. I went trait. Basically, it was looking for a tuple of a single element, which was an instance marker. And this syntax means a tuple of any size where the things in it are instance markers. Okay. So that's a quirk of the traitlet syntax. So I restarted my kernel. Here's my map again. Okay, fine. There's a bunch of marks, etc. And okay, so now it looks good. And then what do? I just do m plus equals, let's give this a name, MC for marker cluster, and then plus equal MC. Let's make sure, okay, there's no marker there. I do this. Oh no, what happened to it?
Yeah, no, there definitely should have been like a circle with a 3 on it or something. Or
let's see. Yeah, is there an MC.visible or something? True. Yeah, and let's look and see if there's any errors. There are some errors. Cannot process kernel message class leaflet marker cluster model not found. Let's see, leaflet marker cluster model not found in Jupyter Leaflet. Okay, so it seems like leaflet marker cluster model. Let's just check to see if leaflet marker cluster model, leaflet marker cluster model. It seems like it couldn't find it. So there it is. And there it is as well.
we didn't get a marker cluster marker backwards or something, right?
Yeah, so I'm just checking. Okay, the actual class is there. Leaflet marker cluster model is there. And it's there. So let's just make sure we have the updated JavaScript here. I know what the problem is. I may know what the problem is. Let's restart the notebook server to make sure. Oh, yeah, actually, it might even work now. I think what the problem is that there's some JavaScript caching going on. So it was getting the old JavaScript file because of the JavaScript caching. So once I open up this, I've set things up so that the opening up the DevTools turns off the JavaScript caching. So now let's refresh. So I'll save and refresh. Because I have DevTools open, the JavaScript caching should actually pull the JavaScript file directly from the, and it still has the same error. So let's see if we can pause on errors, and I'll refresh again. I guess I need to pause on all errors, uncaught exception, right? So right here. So let's see, cannot instantiate that widget. I'm going to switch to Chrome, which I'm more familiar. I've just switched over to Firefox recently. I'm going to switch to Chrome, which I'm much more familiar with in debugging here.
Why did you switch to Firefox?
Firefox 57 came out, and I thought I would give it a shot. And overall, it's actually pretty nice. So first of all, make sure it's not working. Yep, it's not working. But I'm much more used to the debugging stuff in Chrome, and it looks like I even got a Chrome update. So let's pause on all exceptions, and Let's run these cells again. Okay, so class not found in the module. So let's look at this module here. And oh, actually, we could probably just go down to the console here. And let's check. Marker cluster. Yeah, these are alphabetized. And there is no marker cluster. So let's look at the actual JavaScript. NB extension, Jupyter Leaflet. It looks like the JavaScript has not been web-packed. Yeah, there's no marker cluster in that JavaScript there. And the extension is just a small one. So it looks like there's just a build step that's missing. So let's open up a new thing and let's see. If I remember right, build step is something like setup.py.js steps. There's a bunch of build steps in here. Actually, what I usually do is I just run npm run build from here. Let's just check to make sure. It looks like there's a build step right there. So what happened was there was a JavaScript file, and we made changes to JavaScript file, but then those JavaScript files are all packaged together using Webpack into the single file that's sent to the browser. And so our changes to the JavaScript files were not getting packaged up into that single file that's sent to the browser. And so now let's refresh. And we'll take off these errors. All right, there's still an error. Cannot read property _layer add.
Oh, but you got
So
past
let's turn
the
on the
other one,
debugger. Yep, we got past the other one, so that's good. Let's do this again. Layer add. This looks like it's a leaflet thing. It looks like layer is undefined here. Interesting. So let's go up the call stack. Here's the actual function. That.obj. It may be right here. So this is inside, the leaflet map view. The provided object is not, let's see, cannot read property _layer add. So it appears that, let's see, child view. What kind of layer is this thing? Oh, for some reason, the .obj is not getting set. Let's run this again with that breakpoint. Oh, that layer is already on the map. Okay, so we'll create a new layer. Okay, so here, this child view, what kind of view is this? Let's see, marker views. Yeah, this is my marker cluster, as we can see by looking at the it's got the marker views. Or is this? Let's see. Here's the model, and let's. Yeah, marker cluster model. Okay, so the .obj is not getting set. Let's see. Here's the model. Here's the view. Oh, because this is the wrong superclass. Leaflet layer view is the superclass that then calls the create object.
What was it
so
before?
This is map view.
Ah,
So I had skipped a class in the hierarchy here. Okay, so let's try that. So we'll build so it packages it all up. So I copied and pasted, but didn't appropriately modify. Let's see, just run. So there's my breakpoint, but now object is there. Good. For some child object, I'm not sure if. Okay, let's see. I guess we don't need this anymore. How do I cut D, I guess?
yeah.
I still have this problem.
It's different though, right? Yeah.
Possibly different. It's the same. It's the same point. So I'm still have it undefined. Okay, so we jump to conclusions there. This child view is still the marker cluster model, and still the child object is not getting called. So let's put a breakpoint there, and we'll just step through the code here. So here, so create child view. The child model is the leaflet cluster model. So we'll go down inside of here, create child view. Actually, what we should do is actually put a breakpoint here inside of the marker cluster view render, and this is where that object should be being created. Do we need to do new here? I forget. Well, we've got breakpoints in everywhere we need, I think. Let's play it all and start again. All right, create a child view. Okay. Marker cluster. So here I go to this superclass. And what I want is this thing there. So I was calling the superclass of the layer view. I need the superclass of the marker cluster view. Does that make sense? I was saying layer view super, but really I wanted this class dot super. Sorry, I'm used to working in TypeScript now that does that boilerplate for you. Okay. Now if we cross our fingers, let me turn off all the breakpoints. And refresh. Oh, there weren't any JavaScript errors. I don't think there were JavaScript errors. No, it's still not. There still seems to be an issue. Turning back on our Java breakpoints. Okay, this might be the last thing, and then I really do need to pick this up some other place.
Yeah.
Let's see what we can find here. So create child view, great. And then there's the marker cluster. We'll step through that. And now we're actually creating the object. So this .obj is this new class thing that looks like it's reasonable. Okay. And it calls leaflet events. It calls model events. Let's make sure that that is doing, so listen to any change in markers. What may be happening is there's no initialization here. So the initial markers list, we can check that in just a second here. Okay. Yeah, so let's, and here's the leaflet map view. Okay, so we can, so let's check it by doing this. MC dot markers equals, I'm going to make a copy of this list here. No, it's not there. And the other way to check it is right here is where it actually gets added to the object in here. So let's see if that's ever called. Okay, render create object. So it was never called, and then when I set a new value, it's not being called either. Okay, so we're getting all the way to the point of just doing this. So let's do one more step, and that is let's see, there's no initialization in here, but probably in the model events, or maybe right here after we construct that, we'll call this function once. This dot markers view. This dot marker underscore views dot update. So we call this the very first time. Okay. Let's see if that initially populates it. So refresh. So now the add layer model is being called. Quite a few times. There's something there. Look, it's there.
What?
Yeah, so the only thing we're missing now is the CSS.
Yeah. Awesome. Wow.
Okay. So let's see if we can actually construct it here. Maybe it was there before and we didn't notice it. I guess it wasn't there because we were noticing it. Okay. All this is being called. And yeah, there's a 4. There was like 2 4s, right? Okay.
Yeah.
And then if you reset it, or let's, make a few less markers. So I've updated it, and now it's only 2.
Nice.
Nice. Okay, so now the only thing's missing is the CSS. And presumably there's some CSS for this package. In each case, use files. Let's see. So it looks like these 2 are the things that we need. And the question is, where is the CSS in this package? see, it's in the JS probably. Source, any CSS in here? Maybe in the index. Yep, looks like here's where it is. So we'll just mirror this. Marker cluster, I assume it's dist. Let's see, in the dist folder, marker cluster.css. And the default CSS. And we don't need that JS because that's what we're already importing.
Yeah.
Okay, so let's build that. So that pulls this CSS in, packages it up using Webpack. And now cross your fingers. Let's turn off all the breakpoints. Things should just work. We'll refresh. Oh, you saw it.
Yeah, I saw it.
It was there. Okay, there's a bunch of marks. Okay, there's where I added the marker cluster.
Yay!
There it is.
Woo!
Nice. And then, well, all the markers are on the same spot, so they won't ever, right?
Yeah,
But maybe if we add a new marker cluster with the new map center, let's see. So here's a new marker cluster.
Or just add a tiny bit to one of those. Well, no. Yeah, never mind. Yeah.
Yeah, there we go.
And if you back out, they should merge,
So,
I guess. If
yeah,
going back out.
Oh, I don't know what's happening here. Oh, because they're not part of the same marker cluster. So really what we should do is add, now we're sort of offset and add it to the same marker cluster. So MC dot markers plus equals, and then give it a new thing. Okay, and now those two. Yep, there you go. You saw them merge.
Nice.
Nice. Okay.
Yeah, good work.
So now it's it worked. So now make a new branch. Now I've done terrible with not changing. I didn't commit as we were going, but I'm just gonna.
It's okay.
Let's see. It looks like that's fine. Looks like that's fine. Looks like that's fine. And I guess technically we should. There was this fix that I'll actually do in a different commit.
Yeah.
And the same thing with here, the layer group fix. Okay, so add marker cluster for feature. And then fix model name for layer group. And then git push. I guess I don't have my repo, so I'm just going to take this all the way to the end of submitting a PR here.
Nice. So you had you forked or no?
I did fork. Yeah, I guess that I do know I have a fork. So I would do fork, and then I would click on my username, but I already have one right here. Mm-hmm. So I'll copy this, get push JSON marker cluster. So that pushes the branch. Mm-hmm. Go back to this. Compare and pull request. And really, I should have
made a test or something. No.
Well, no, I should have put fixes in the PR in the actual commit message, but there we go. Okay, so now somebody needs to just test it and then merge it. So I think we're good.
Awesome. Well, Jason, thank you so much for. I think hopefully there'll be, you'll get paid back. Well, not you. I mean, well, yeah. Hopefully you could benefit from something somewhere down this road. Hopefully you'll benefit from somebody that either was on this call or has watched the recording and has added something to Ipi Leaflet that you find useful. I hope, or another way.
That'd be great. Yep, that'd be great. And if, yeah, again, feel free to reach out, for questions and things like that. We want to help you guys get up to speed.
Awesome. Thanks again.
All right.
It's great.
Yep, thank you.
See you.
Okay.
Bye-bye.
Bye.